Welcome back. Now we're continuing with our decimals. I have an example here in which we want to apply or we want to round off given decimals to a specific number of significant figures. Alright, so in this example we've got the question number 1. Express on part A we've got 1.3437 correct to 3 significant figures, and on part B we've got 0.02474 correct to 2 significant figures. Alright, so this is how we do it. We're just going to be using this example to illustrate or to show how we convert, or how we express rather, a given decimal correct to a specified number of significant figures. So on part A we've got 1.3437, which needs to be rounded off to 3 significant figures. So what do we mean when we talk about significant figures? How do we correct or round off a given decimal correct to a number of significant figures? Well, what you simply do is you start counting your figures from left to right, starting with the first non-zero digit. You're starting from left going to right, and you start with the first non-zero digit, which means that on part A what I'm going to be doing here is I go on to the first non-zero digit, which is 1. I go on to the second, I go on to the third. Since I want to correct it to 3 significant figures, I'll end right there, so I'll break it from here. Alright, so these now are my 3 significant figures, and before I just write them down, then what I'm gonna do is I look at the number that is in front of the third significant figure. In this case we've got 3, and if this number is less than 5, the digit to its, or the figure to its left, won't change. So the digit to its left won't change, which is our third significant figure, which is 4. It won't change if that number is less than 5. In this case we've got 3, which is less than 5, then so that means that 4 won't change. But if had it been a case that the figure or the digit 3, or that is after 4, was greater than or equal to 5, then the number to its left would increase by 1, although that is not the case in our situation. So on part A our solution will come out as 1.34 to 3 significant figures. Alright, so that's part A. Let's go on to part B to see if we have an idea now of how we correct a given decimal to a number of decimal places. We've got 0.02474. Alright, so remember what we say. We start counting figures from left to right, starting with the non-zero digits. So in this case 0 is a 0 digit, and this one as well, so these two are not significant figures. We start from 2, so that's the first, and 4 is the second, and remember we only want 2 significant figures. Alright, so we now have our 2 significant figures right there. So we break it from here and we look at the number that is ahead of our second significant figure, which is 7, and it is greater than 5. So since it's greater than 5, then recall what we said, just say it right there. We say that if the number to its left, so the number to its left will increase by 1 if it is greater than 5. If the number here just after our second significant figure right here is greater than 5, then the number to its left will increase by 1. That means 4 will increase by 1 to become 5. So eventually we'll be having our solution as 0.025 to 2 significant figures. Right? Alright, so let's go on to part B. On part B we want to express 0.04506, right, and we want to express it to how many significant figures? Correct to 4 significant figures. Right, so this example, I'm gonna leave it to you. I'm gonna give you just 2 minutes or just a minute just to work this one out. Just less than a minute. I don't think it should take you much time. Just round this correct to 4 significant figures. I'm just giving you a couple of seconds. Alright, so what answer did you get? We have 0.045067. We want to round that off to 4 significant figures. So with our 0.450671, my solution has come out as 0.04507, and I hope you got that one correct. Right, so look what I did. I looked at the first significant figure. I had 4 and 5, and that 0 is also significant in this case, and also 6 is also significant. So these are my 4 significant figures, and I broke it from there. And I looked at 7, and I discovered that 7 is greater than 5, so that means that this 6 will increase by 1 according to what we said. So it has to become 7. So my solution will now come out as 0.04507 as my final answer.